those and tell me which one doesn't belong. Remember, this is one where there are multiple answers, so your answer may differ from someone else's. Go ahead, Evan. B or D? E. Why? Okay, it's the only one that has a negative slope. Who else was thinking that? Okay. Anyone else? Ellie?
B, because it's the only one that goes straight through the middle.
Okay. So all the other ones go through different points, but this is the only one that goes through the origin, the middle. Was anyone else thinking that? Okay. Ace?
C, because it's the only one that goes through one of the axes.
Okay. Technically, eventually, this is going to go through that one also, but what we see, it's only going through one. Anyone else think that thought? Or have a different reason why C wouldn't belong? Okay. What about A? Why would A not belong? How was that different than the others? Do they cross at the same places? Does it look about the same amount, steepness-wise? So we could, some of the other classes said that this is the only one that has a negative x-intercept. So if you were thinking where it crosses the x-axis, this one has a negative. Okay. Has a negative x-intercept. If we're looking at slopes, this one maybe has a slope of like 1-ish. This one is more like a fraction. We talked about that one having a negative. This one's steeper type thing. But we'll be talking more about those transformations here in a moment. So you guys started, you may have finished, you may have not, but that's all right. We're going to actually talk about transformation. So everyone should have these notes. So go ahead and close your computer. So everyone should have these notes in front of them. Right. I'm going to read through a lot of the definitions, so highlight, underline, whatever you feel like you need to first, and then we'll get into actually how do we do this. So when you guys started exploring transformations, you were talking about like what does transformation mean and how the A and C sliders were affecting the line. So this is our objective. Notice that it's different than slope. This is its own thing, transformations. It kind of ties into the slope stuff because we need slope in order to do this. The actual definition of transformation is the change. It changes the position of a size or figure. They'll do more transformations in geometry. We'll just focus on some function transformations with linear, some quadratic later, some exponential later. And then there are different types. One is a translation or a shift. You can use those words interchangeably. And it moves a figure, usually up, down, left, or right. Mostly we're going to be talking about up and down, vertical translations. And in the activity in the exploration, you were seeing C, that's the same as K here. In general, you'll see K and not C as the all functions vertical translation. So if I have some plus or minus K, it's being translated up or down. So if it's plus K, the y-intercept is translated or shifted up. And then if it's minus K, the y-intercept is translated or shifted down. So we need to keep those words together. Y-intercept translated or y-intercept shifted, and it moves up or down. And then we're going to talk about dilations a little bit, but for linear, that just means the change in the steepness. So if your A value here, it was A value on the exploration, but that's really like your slope, which is M, but you'll see it as A in like all functions. If that number is greater than 1, 2, 3, 5, keep going, that is steeper. The line is steeper, the slope is steeper, or you could say it's 5 times as steep. But if that number is between 0 and 1, so like 1/2, 3/4, some fraction where the decimal would be in between 0 and 1, not like 3/2 where that would be 1.5, because that would be greater, that would be less steep, or I could say that's half as steep, 1/3 as steep, and so on and so forth. And then slope actually has 2 different transformations that can happen. The dilation, the steepness, we can change that, or the reflection. If we have a negative out front, or if the slope is negative, we say the slope has been reflected. So when we talk about slope, we want to keep that negative together. It's negative, whatever. But when we talk about transformations, the steepness and the reflection are 2 separate things, and you have to keep that separate. So then we're given some problems where we have to describe the transformations. We want to always compare to this equation. Y equals x. So this is like the original, the parent function, you might see it called. What is the slope of this equation? Of this one, it's 1. It's invisible, it's in front of x. There is an invisible 1. And what is the y-intercept of this equation? 0. There isn't 1, so assume it to be 0. So we are always going to compare that to whatever our equation is. So from this to our number 1 problem, what's different? What changed? The y-intercept? So we're only talking about slope and y-intercept here. Okay. So the negative, I'm color coding. You don't have to do this, but you can if you want. The slope is now negative. That would tell us the slope has been reflected. What about that line? Use the words up here. So I do see the y-intercept has changed, but using our transformation vocabulary, what did it do?
Shift it up.
Shifted up by 2. Right. And then one last thing happened. We know the slope was reflected, but also the numerical value of the slope has changed to 1/3. And that talks about steepness. Is the slope now steeper or less steep? Less steep because of that fraction. I'm going to say 1/3 as steep, or you can say less steep by 1/3, either or. Do we have any questions so far on how we got those? This is a lot of knowing the vocabulary and describing slope and y-intercept with those things. All right, let's try the second one. Again, we're comparing from the original, not this one. What's different? Okay, so what does that tell us using our vocabulary? what is that? 3. So shifts are for y-intercept only. Robert? So vertical translations and shifts are for y-intercepts only. So it is a dilation. Which type is it? Is steepness? Is it steeper or less steep? Steeper because it's 3. Yes. So I can say slope is steeper by 3. Anytime it changes the numerical value, you have to say what it's doing, by how much, for y-intercept, in what direction. What else changed?
The y-intercept was shifted down.
Yes. So the y-intercept was shifted down to once you have that, go on to the back. So we're going to do the same thing, describe these again, but we're also going to graph them using those descriptions. Before we do that, there was supposed to be this same line here, so I'm going to draw that really quickly. This starts at 0, 0, so I'm going to plot a point there. The slope of this line should be the same slope as this one, which is what? What are you going to say? It is positive. What is that number?
1.
1. So we're going to go up 1, right 1, plot a point, and do that. Keep going. Fill up your graph. And then I'm going to do that in the opposite direction. Go down 1 and left 1, and plot a point at every point on the graph. Then I'm going to draw a line through all of those points, and make sure you have arrows at the end. These lines go on forever and ever. Okay, so let's describe first, and then we'll come back and graph it. The original is up here. Remember, we're thinking slope of 1, y-intercept of 0 for the original. How did it change? Reflected is for slope. So you can turn back, look back if you need to see that vocabulary. The y-intercept is what? Shifted down 4. There we go. Okay. Did the slope change?
Nope.
No. So even though it didn't change, we still need to, since we're describing everything, we need to state it stayed the same or that it didn't change. And then to graph this, the y-intercept shifted down 4. So it was at 0 and it shifted down 4. So I'm just going to move this down 4 points. And plot a new point. Plot a new y-intercept. And then since my slope stayed the same, whatever the slope was, I'm going to draw those new points on this. So the slope was 1, so I'm going to go up 1, right 1 as many times as possible. And fill up my graph. And then do the same thing the other direction. Down 1, left 1, and fill up my graph. And then draw a line through all of those points. And make a line. have any questions about that?
You said down 4, right?
Mm-hmm. The y-intercept.
Down 5, 1, 2, 3, 4. Oh.
That's okay. Other questions about that one before we do number 4? Okay. What changed in this one from the original?
It reflected.
What reflected?
Slope.
Yes, the slope reflected. Did it shift down? Did it change at all?
Yeah, it's like, it's up.
Do you see a y-intercept here?
I think that.
We're always comparing to the original. So then the y-intercept stays the same. So then here, the y-intercept stays the same, so I'm going to plot it on the same point it's already at the middle, at the origin. The numeric number hasn't changed, so whatever the slope is, it's going to be the same. I'm just going to make it negative now. So the slope was 1. I'm just now going to go up 1 and to the left 1 instead. And fill up my graph. And then go back to the y-intercept and go down 1, right 1. Please stop. There we go. And then draw that line through that. AJ, do you have your notes? Okay, make sure you're taking them. Questions about either of those? Alright. The next two are similar, but now we're not graphing, we're just describing, but they kind of give us the descriptions. So in number 5, y1 is x. So that's our original. They gave it to us. Our y2 is some other equation. We're comparing the two. The graph, so when it says graph, it's just talking about the equation, the function. The graph of y2 is shifted up or down from graph 1. Which one? Down. Why do you say down? The y-intercept? So it would be up. So this one would be up because the y-intercept was 0, it's now 5. The graph of y2 is steeper or less steep than the graph of y1. Ellie? Why do you say that? So looking at just this number, sure, that number is positive, but the positive number has nothing to do with the steepness. What the actual number is depends on it.
So it's less steep.
So since this fraction is less than 1, between 0 and 1 is less. If this was 2 or 3 or 5, keep going to infinity, then it would be steeper. And then the negative does what?
Reflects the first.
The negative reflects the slope. Once you get those 3 vocab words and what they do, what they affect in your mind, you can do all of these problems. Questions on that before we go on? 6 is similar, but now they're actually telling you, okay, the slope is doing what, and then the y-intercept is doing what. So in the first part, the slope of y2 is divided by 5, 5 less than, 5 times more, or 5 more than the graph of y1. Which of those is accurate?
D.
5 more than? So if we were comparing the slope and we were trying to get 1 to 5, if I added 5 to 1, would we get 5? So not C, but B would work. Okay. Because if I multiply 5 and 1, I would get 5. In general, your slope is either going to be divided or multiplied by, depending on if it's a fraction or a whole number. And then the y-intercept of y2 is divided by 2, 2 less than, 2 more than, or 2 times more, I think I switched those, than the graph of y1. Did we add 2? 2 less than. Should be 2 less than. So in general, your y-intercept is adding or subtracting. Slope is multiplying or dividing. Keep those separate as well. Questions there before we do this last one? Before you guys do this last one. Okay. So I'm going to talk through this, and then you're going to try this, and then we'll come back and talk about it. So we have the original. For the second one, it's telling you what is happening. It's been shifted up 5 units, and it's 1/2, that's just a typo, it should be steep, 1/2 as steep. And you need to plot 6 points that would make that line. My hints to you are figure out which one is the y-intercept, start with that one. Then whichever one is the slope, apply that one. Try that. I'll give you a couple minutes to do that, and then we'll come back and talk about it. Great, so your 6 points should have looked like this. Your y-intercept was the shifted up 5, so we would have started at looked at the y-intercept at the original, and then went up 5. So that point should have been right there. And then your slope is 1/2 as steep. So that means we're going to go up 1 and to the right 2. As many times as possible that way, and then go down 1 to the left 2 from your y-intercept. And that should give you your 6 points. And then make a line through it. Who all got that? I know there were a few of us. So hopefully with practice, this starts to become a little bit more clear. We're going to do 2 more problems, then you're going to have a chance to practice this. So go on to the back. Okay, so just like before, we're going to sketch the graph and describe. And when we get into just graphing, you can do this process all the time. So remember, your original is y equals x. If you need to write that, you can write that. What changed from the original to this one?
The slope is 6 times.
Okay, the slope is 6 times the steep. Whoa. The y-intercept shifted down. That means my new y-intercept would start at -5, and I would go up 6 to the right 1. Your whole numbers are really fractions. Really, you're only going to be able to do this one. If you do the next one, you'll end up off the graph. Up there. If you do that point, you don't need to, though. And then draw your line. For the second one, what changed? Nothing. Everything stayed the same. So I would say slope and y-intercept stayed the same. I would go ahead and graph that, starting at my y-intercept, which is 0. And then the slope is 1. Up 1, right 1 as many times as possible. And left 1, down 1, left 1 as many times as possible. Right. You guys are going to do an assignment that isn't due until Friday, but you also have other assignments due on Friday, so if you can knock this out in class right now, that's one less thing to worry about. So go ahead and open your iPads. You should be on campus. Log into yours. On I think the fastest way to get there. Go into your announcements. What was the last one for you guys? 28. And then go into the Desmos practice for transformation. And click that. And then you're going to go into Desmos. And then one of two things is going to happen. You're going to go into Desmos and sign in, log in with Desmos if you already made your Desmos account and linked to the class code. If you've not done that, and I have to unlock iPads. If you've not done that, you'll need to join Desmos using the class code from the class resources. If you need help with either of those, I will help you with that. Once the iPads unlock, you will be able to go into Desmos. On the same page, all of this is written out for you, so you don't have to write this. Notice that this is the same objective as the slope. All of those fall under the same objective, but now we're just talking about intercepts. So graphically, and you may have, this may be reviewed for you, and great if it is, if it's new, that's also fine. Graphically for x-intercepts, where the point crosses, touches, intersects the x-axis. Algebraically, where y equals 0. For the y-intercept, it's opposite. Graphically, it's where the graph touches, crosses, intersects the y-axis. Algebraically, the x is 0. When we write our intercepts, they should be in ordered pairs. And then you may also see some of these words. X-intercepts are also known as roots. Go more with quadratics. Solutions, we kind of talked about that with slopes. And zeros. So if you see, find the zeros, it's talking about x-intercepts. Find the roots, or find the solutions, it's talking about x-intercepts. So from these graphs, we're going to find the x and y intercepts from the graph. So if you need to highlight the x and y intercept just so it is a little bit easier to read, we're looking at where does this diagonal line cross the x-axis. Say it again. 2. And we would write that as, in parentheses, 2, 0. Where does that line cross the y-axis? -3. And we would write that as 0, -3. Questions on that before we continue? Okay, for number 2, you may have multiple x-intercepts. What are they? Positive 4 and positive 2?
-4.
-4, 0 is how we would write that. And then, okay, I'm writing in highlighter. And 2, 0. What about the y-intercept? It's 8. How would I write that?
0.
0, 0, 8. in parentheses. A couple more, and then you'll do this activity really quickly. For number 3, what are the x-intercepts? Okay, read those to me in order pairs. How would I write that? Okay, negative 5, 0, and 5, 0. And then for the y-intercepts? 0, negative 5, and 0, 5. So the most important thing when we're writing our intercepts is, are we writing it in the correct format, order pairs, but also did we put the x and y in the correct place, not switching them. Alright, last one, number 6. X-intercepts. Where does this cross the x-axis? Negative 5, 0, 0, 0, and 3, 0. We're just doing whatever it wants today. And then y-intercept. 0, 0. They share one. Okay, so then for the remainder of class, you're going to do this next thing. If you finish it and want to start on the back of this page or finishing this, you could do that. Or if you want to start on the intercepts discussion / the intercepts delta math, you could do that. But we will continue this next class, so don't feel like you have to do that. So on Canvas, you're going to go back to the home page. Click on the Unit 2. You may have to scroll, you may not. So go back to the home page. Click on Unit 2. If you didn't finish the transformations, you can also be working on that after you finish this. Once this looks, if it decides to look. There we go. Now I read. In the Unit 2 module, find the intercepts lesson. And you're going to go into, I went too far. I want to say this is in additional practice. Yeah, so in the intercepts additional practice, there's a Desmos activity. You may be able to log in with Desmos, but my last classes were having issues. You could also just continue without signing in. This one is not, I'm not putting this in anywhere. I just want you to explore intercepts with it. You can move around with this and work together, but everyone should be doing this. So you can continue without signing in. That'll probably be the fastest. Or if you want to try logging in with Desmos, you can also do that. Do that, and then you can be working on finishing the transformations, this discussion, this delta math, slope delta math if you didn't finish that.